Hi everyone, so I'm just doing a relaxing Friday night build, and tonight I'm building a radio controlled car. So what I'm going to use one of these cheapish robot chassis that you get off AliExpress, and they come with 4 DC motors. Some of them come with 2 motors, and they come with wheels and the plastic chassis. I'm going to use a joystick, just a Arduino joystick, a DC to DC. I think this is a buck converter because I'm going to use this battery here, which puts out 7.4 volts and 8 volts if it's fully charged. So I've got two motor drivers. These are dual H-bridge MOSFET motor drivers, which are a little bit more efficient than the LM298Ns, but they don't put out as much current. But I don't think I'm really going to need that much current anyway for these DC motors here. And then I've got some push buttons, and I've got 2 ESP-NOW, one for the car and one for the remote control. So I'm going to use ESP-NOW for the remote control, and the reason I want to do that is, well, firstly, I'm going to say a lot of the remote control cars that I've seen on YouTube videos and Instructables and places like that use either an RF24L01 transmitter receiver pair, Bluetooth, or wireless. And the reason I don't want to use any of those is because, well, with the RF24L01 receiver transmitter pair, I've worked with those before, and they can be very fiddly and quite difficult to get to work. And then with the Bluetooth, it requires a particular app for your phone, and it requires, I guess, a phone or a device to use. So if I wanted like my kids to use it or something, they'd have to take my phone. And then I guess with the wireless, I guess as well as requiring a phone, it requires a wireless network. And the other reason I wanted to use the ESP-NOW for this build was because I wanted to test the distance over which the ESP-NOW works. So a good way to do that is to, I guess, build a remote control car, and I can see how far away I can be before the car stops working. And that'll just give me an idea for future projects over what kind of distance I'm going to get out of ESP-NOW. So I'm going to put all that together and we'll see how that goes. So I did what I always do when I'm starting a new project, which is go over to random nerd tutorials and see what pins I should use. And so for this, I'm using the joystick, and I'm also going to use the pot here to control the speed. So I need 3 analog to digital converters. And when I was at Random Nerd Tutorials, I discovered that the ESP-8266 only has 1 ADC. And so I've decided I have to replace this with an ESP-32, at least for the remote, and maybe I'll do that same for the car just because it's got more pins on it. But yeah, so I'll wire that in and we'll see how that goes. So hey everyone, so I've wired up the car now. And so what I've done is I've used these MOSFET motor controllers, and I've used 2 of them, one for the front and one for the back. And I've just, for the one side, this is where the inputs are for the ESP-32. And so what I've done is I've just kind of wired them together here. So I've tied this side together on both of them. And then I've just got the same signal coming from the ESP-32 for the front and the back. So I've got the front and the back running at the same speed, and then I've got them separated by left and right. And then the other side, I've got the output signals. So the way this motor controller works is one side is the input signals from the ESP-32, the other side is power and output signals to the motors. So I've got the front motors on this one and the back motors on this one, and I've put a couple of addressable LEDs on just to so basically the hue of these has been linked to the speed of the motor vehicle, And then I'm powering it actually with, this is 4 AA batteries to power the motor, which gives me about 6.5 volts, which for a fully charged battery. And then the power drop, the drop across this is about 0.5 volt, so I'm getting 6 volts into the motor. And then I've got this buck converter here, which is bringing the voltage down to 5 volts just for the LEDs. And I've got a separate battery shield with an 18650 just to power the ESP32. And now I tried connecting the ESP32 to the output of the buck converter, but for some reason it wouldn't work. So I'm not sure what the reason is there. If anyone has any ideas, please put them in the comments. And then this is the top here, so I'm going to put this on, and I'm going to have the lights and the batteries on the top here. And then I've got the remote control over here, which is just wired up to a Tupperware lid, and it's got a potentiometer for the speed, and then a joystick for forwards and backwards, and it's got a little LED here just to tell me it's on or off. So I'm going to test this now by driving it forward and just making sure everything's connected to the right outputs. The motors are connected to the correct outputs. So, all right. So that's going the other way. I wanted it to go on the left side, which basically means I've just got to swap these 2 wires over for the left side, and I should be done. Okay, so I'm going to put that all together now with this lid, and we'll see how that goes, and then I'll take you through the code. Hey everyone, so wired it all together, and I've got the batteries mounted on the top. So this one here is the battery for the motor, and that one there is the battery for the ESP32. And I've got just these ping pong balls acting as diffusers, and the LEDs change colors with the speed and direction of the robot. So I'm going to start it now with my homemade remote, and we'll see how it goes. Right, so that's forward, reverse, right, left. Hi everyone, so I'm just going to go over the sketch for my ESP-NOW RC car, and this is for the car side, which is called car side. And so the first thing I always do is color code my wires that run between the motor controller PCB and the ESP32. So this just makes it easier when I'm connecting everything up. So the libraries I'm using are ESP-NOW and Wi-Fi, and these are the libraries that you need for ESP-NOW. So I've just followed the instructions of the Random Nerd Tutorials website to implement this, to implement the ESP-NOW part, and I'm using the NeoPixel library for the addressable LEDs. So the first thing I do is just initialize the addressable LEDs. So I've got 2 of them on pin 12. So HSV color R and HSV color L are the colors for the left and right LEDs. So I'm using an HSV color space, but I'm only defining the hue. So the saturation, the value I'm setting to 255, and the hue, which is actually a 16-bit unsigned integer, I'm mapping from the speed and direction of the motors to the color wheel. So I mean, HSV is a bit misleading because this is just the hue. So if we have a look at the color wheel, I'm just, because I've got the saturation and the value set at 255, I'm just on the outside edge of this wheel basically. So as I go from 0, and because it's a 16-bit unsigned integer, it goes to 65,535, I go basically around this edge of the wheel. And then the next thing I do here is I define my pins. So these are the pins that I've got the motor controller connected to on the ESP32, PWM-A, PWM-B. RMI1 is right motor input 1, RMI2 is right motor input 2, which is the same as AN1 and AN2. And then LM is, I've just called it RM instead of AN, just to make it easier to remember that it's the right motor. And LMI1 and LMI2 are BN1 and BN2. And then these are on pin 25, 26, 27, and 33. And these are just high or low. They don't take any value, whereas the PWMA and PWMB take a value between 0 and 255 because they control the speed. These control the direction. And the standby, I've set standby to 34, but I actually didn't end up using the standby pin. I just kept it high. So I just connected it to the 3.3 volt output of the ESP32. So these are the PWM channels for setting up the PWM channels of the ESP32, and I'm using channel 2 for the left and channel 4 for the right. And I generally avoid using channel 0, and the reason why I do that is because if I'm using some other library that uses a PWM signal, often I find these external libraries, when they use PWM, they'll default to channel 0, or they'll look for the first one that's basically not being used, and because it doesn't know that it's being used, if you're using it, it wouldn't know that it's being used in the code, so it would just default to channel 0, and that would interfere with your code. I mean, I'm not using any of those libraries in this particular project, but I just generally avoid channel 0 when I'm on the ESP32. And then this is the structure for the message. So this is what's received from the control, and T1 is the X value, T2 is the Y value, speed val is the value from the speed potentiometer, and brake val is basically if the button on the joystick has been pressed. So this is basically just like an emergency stop. So if this is being pressed, which is it goes low if it's been pressed, then the car will stop. And then it's got the same structure defined in the transmitter sketch as well. And then this is robot stop. So basically, to stop the robot, you just set all the binary inputs to low, and I'll show you on the data sheet. So this is the data sheet here, and for the TB12FNG motor controller, and so it gives you a table. It gives you a table which shows you what all your inputs here, and these are your outputs. So it shows you how your outputs correspond to your inputs. So when your IN1 and IN2 are low, both low, basically it turns it off, which is a stop. So this is basically just like stopping the car. And then when one's low, one's high, it goes counterclockwise. CCW is counterclockwise, and then high, low, clockwise. CW is clockwise. But of course, it depends which way you've got your motor facing. And then robot setup. So I guess the most important part of this robot setup is, so we've set all these pins to output, which are driving the motor drive. But the most important thing here is setting up the PWM channels. And then left motor drive, basically this just sets the direction and the speed of the motor, the left motors, and so we've got the two left motors kind of tied together and the two right motors tied together, and the right motor drive does exactly the same, but except for the right motor pins, a right motor PWM channel. And now this is the data receive function that gets executed every time there's an ESP-NOW communication from the control. So this gets executed on the receiver side. So basically what we do is we read the control data, which is defined here as this this data structure. So this is our control data here, and we just allocate all these values. And then if the brake val is 0, so if we press the emergency stop button, we stop the robot. Otherwise, we update the robot based on whatever these values are. So now T2 is my Y value, and the Y values, so the joystick is basically just a potentiometer connected to an analog to digital converter, which is 12-bit, so it can be anywhere between 0 and 4095 included. But if it's greater than 1850, I send it forward. And now the midpoint is around about 2047, but I'm biasing it a little bit. Well, firstly, I found when I tested it, it was a little bit biased. But the other thing is, it's because when I'm controlling the robot, I want to control it forward. So if I did want to move, if I accidentally, had it on the edge, I'd probably be wanting to move it forward. And then if I want to move it backwards, I'm going to make sure that it's actually well defined backward, if that makes sense. So then, so the forward speed is updated based on the Y direction, and then the left and right speed is updated based on the X direction, which is T1. And you can have a look at all of this, and I'll put the code up on GitHub. So if you've got any questions, just leave them in the comment. And then the HSV color R, which is basically just the hue, is mapped from the direction times the speed so for the right it's 3000 to 32,000, and for the left it's 35,000 to 62,000. So basically, if we have a look at the color wheel, for the right it's on this side of the color wheel, and for the left I've got it mapped on this side of the color wheel. But when I filmed the car, it didn't actually come out very well on my iPhone. It looks a lot better in real life. So then I just update the LEDs with the Arduino NeoPixel library and pixel.show. You've always got to remember your pixel.show. Know how many times I've forgotten this and wondered if my LEDs are broken. And then I call the left motor and right motor drive functions to update the speed and direction of the motors. And now this is the setup. So basically I just call the robot setup function, and then I stop the robot just to make sure it's not going to move anywhere before I actually start controlling it. And then initialize the ESP-NOW, which, like I said, I just got the instructions for doing this off Random Nerd Tutorials. And now this is basically in the loop. All I do is I check that it's been at least half a second since my last communication, and if it hasn't been, then I stop the robot. So basically, if I move the robot forward and then my controller brakes and the robot's got this instruction to move forward and it's going to run off, so I make sure that it's if it's going, it's got to be in constant communication with the control, or else it's going to stop. So this last last communication, gets updated in the onReceive data function here. So that gets updated. So every time we receive data, that gets reset. So basically if it gets out of range or something and I'm pressing it, then it won't keep going forward and run off. Okay, so that's all the code for the receiver side. Hey everyone, so I'm just going to go through the transmitter side sketch, which is running the remote control, and I've called it remote side. I'm not going to go over it in detail because it is up on GitHub, but there are a couple of things that I do want to mention. The first thing is that you need the MAC address of the receiver side. So the ESP32 that's connected to the car, you need to get that MAC address, and the instructions on how to get that are on Random Nerd Tutorials, and I've referenced that here. So you don't need the MAC address for the receiver, you only need the MAC address for the transmitter. So the receiver side of MAC address has to go on the transmitter side sketch. And the other thing I wanted to show you, which is quite important, is that, so I've got the joystick and the potentiometer connected to the analog to digital converter inputs of the ESP32. So the joystick has two. It has an X pin and a Y pin, and I guess the pot only has one. But so the analog read function reads into a 12-bit register. So I have to convert that to 16 bits. I have to convert that to an unsigned 16-bit integer because my data structure that I'm transmitting on ESP-NOW takes an unsigned 16-bit integer, so basically 2 bytes. So to do that, I've used a bitwise OR with an unsigned integer value of 0. So just bitwise ORing it all zeros. So it's just going to, basically all that's going to do is going to convert this 12-bit number into a 16-bit unsigned integer. And if we don't do that, what it does is it tries to pack everything into this control data structure, which is the structure that I'm sending to the receiver side, and then everything works fine on this side, on the transmitter side, but the receiver side crashes. And this is a pretty difficult thing to debug because, you know, it's the receiver side that's crashing. So I thought, oh, there's something wrong with the receiver side, but it was actually the transmitter side that was just not filling the control data structure properly. So just remember to do that, otherwise it won't work. So that's the end of the sketch, and now we'll take a look at what kind of distance we can get out of the ESP-NOW, which is using an onboard aerial. It's not using an external antenna. Okay, so I'm going to go right over the other end of the house and see if I can get it to still work, to see how far it goes with the ESP-NOW. And I'm just going to leave, so I'm going to go right to the other end of the house, and I'm just going to leave the phone here, and we'll see if it moves. Okay, so it worked from the other end of the house, and now I'm going to have to try something different. I'm going to have to go outside. So I'll see you outside in the next scene. So I'm outside now, and it's a beautiful day outside, and I'm just going to see how far I can get the car down this path. That green box is about 30 meters away. So here goes. And it's fairly windy, and it's very difficult to control the car and hold the camera at the same time. Now I'm talking over this, I've dubbed over this because there was a lot of noise in the background from the passing cars and the wind. So I'm just going to have to make a bit of commentary, just like a cricket commentator, I guess, trying to make things up when there's nothing going on. So the car's just seems to be working at this distance. I think that's probably about 20 meters so far, given that box is about 30 meters away. And here come a couple of dogs down the street, walking towards us. And these dogs get pretty freaked out by the car. So when I get to the dogs, I stop recording, but it gets just past that green box and then it stops. Hey everyone. So the last thing I've done is to replace this battery pack, which is the 4AA's, with this dual cell LiPo battery. So fully charged, the LiPo battery is about 8.4 volts, and I measured it, and there's about a 0.7 volt drop across the motor controllers, so I should get about 7.7 volts on the motors, which is probably a bit much for these motors, which are rated at about 6 volts. And all the forums say you shouldn't drive the motors with too much voltage, but it does go a lot faster with this battery, so it is going to be a lot more fun. All right, we'll see how this goes. So I've got my homemade remote now. Wow, that is a lot faster.